Hey y'all. Today we're gonna be simplifying radicals. So yesterday we started by taking a look at what a radical function looks like. So the parent one starts at the origin and it kind of curves over and is solely in the first quadrant. Today we'll get into how to simplify a radical, meaning your square root. We'll talk about what an index is, and then in the coming days we'll do some other stuff with radicals like add them, subtract them, multiply, and divide them. So let's go ahead and jump right in. So we know how to take the square root of like 25. So the square root of 25 is 5. The square root of 36 is 6 and things like that. But what if the number is not a perfect square number? We still can simplify it and we still can break it down. So I'm going to show you how to do that today. So we do not want these in decimal forms. We want the exact answer in a simplified square root. So in a simplified radical. So the first one is the square root of 18. Now, there's a little number on the outside called an index. So this number on the outside is called the index. Most of the time, you do not see it because it's assumed to be the number 2. So if you see a square root and there's no number on the outside, that assumed number is the number 2. So in a few more examples, as I go down, we'll change the index to 3 or we'll change the index to 4. But for right now, we'll start with some problems where the index is the number 2. So we want to do a factor tree, and we're going to break down 18. Doesn't matter where you start your factor tree with, as long as you start with 2 numbers that multiply to give you that number that you started with. So I'm going to do 6 and 3. Break 6 down, I'm going to do 3 and 2. Whatever your index is tells you what groups you're looking for. So in this case, my index is 2, so I'm looking for 2 of the same number. If my index was 3, I'd be looking for 3 of the same number. If my index was 4, I'd be looking for 4 of the same number, etc. and so on. But in this case, I'm looking for 2 of the same number. So I see 2 3s. Complete groups go on the outside. So complete groups, I got a complete group of 3 there. Leftover prime numbers go on the inside. So if I have a leftover prime number here, is the number 2. So this is my final answer. So if I break down the square root of 18, I'm going to do a factor tree. It doesn't matter where you start your factor tree with, as long as you start with 2 things that multiply to give you that number. I'm looking for groups of 2. Complete groups go on the outside, and leftover prime numbers go on the inside. So complete groups on the outside, leftover prime numbers on the inside. And if you had multiple groups, you would multiply those. All right, next. We're going to break down 28. Again, I do not see anything there, so my assumed index is the number 2. And we're going to do a factor tree. So it's going to give me 7 and 4. It's going to give me 2 and 2. And I'm looking for 2 of the same number. There we have it. We have 2 2s. Complete groups go on the outside, and leftover prime numbers go on the inside. So just like that, we have simplified the square root of 28, and it simplifies to 2 square roots of 7. Number 3, break it on down. Let's do 18 times 10. So if I break 18 down, let's do 9 and 2. Break 9 down, 3 and 3. Break 10 down, 2 and 5. So I just did a factor tree. My index is 2. So when you don't see it, index is 2. So I'm looking for 2 of the same number. I see 2 3s and I see 2 2s. So both of these go on the outside of your square root because complete groups go on the outside. So this is 2 times 3. And leftover prime numbers go on the inside. So my leftover prime number is the number 5 that goes on the inside. 2 times 3 is 6. So my final answer is 6 square root of 5. So final answer, 6 square root of 5. All right, number 4. Now, this is the first one where I have a variable involved, but I'm still going to go through and do the same thing. So we're going to do a factor tree, and then I'll show you what to do with your variable. So I'm going to go ahead and put the 2 on the outside so we don't forget that that's what we're looking for. We're looking for 2 of the same number. So I'm going to break down 12. 12, let's do 4 and 3. I'm going to break down 4, that's 2 and 2. Now with the variable, one way to do your variable, you can write out however many of these that you have. So you can write out 6 C's. 1, 2, 3, 4, 5, 6. And you can write out 3 D's. So 1, 2, 3. Your index is 2, so we're looking for 2 of the same number. So, okay. So I got 2 C's here I can pair together, 2 C's, 2 C's, and 2 D's. So I went through and I paired those together because I was looking for groups of 2. I was looking for a pair. And I got a pair of 2's. So complete groups go on the outside of your square root. So on the outside of my square root, I got the number 2. And I have 1, 2, 3 groups of C's. So that is C to the third. So again, that's a group, that's a group, that's a group. Complete groups. I had 3 C groups. And I have 1 D. So that goes on the outside of the square root. On the inside of the square root is leftover prime numbers or leftover variables. So leftover prime number, I got the number 3. I don't have any C's left over, but I have 1 D that was left over, so that has to go on the inside. So this is our final answer. So the square root of 12, C to the 6th, D to the third, simplifies to 2 C to the third D times the square root of 3D. So that is our final answer. Now, shortcut. Because I see coming up on number 5, I got 12 Y's, I got 16 G's down here, 24 H's. I do not want you writing out all of those variables. Shortcut, you can just divide. 6 divided by 2 is 3. And 3 divided by 2, I have 1 complete group that goes on the outside and then leftovers on the inside. So you can think in terms of division. So again, 2 goes into 6 3 complete times. 2 goes into 3 once, and then I have 1 that's left over. So complete groups on the outside, everything else on the inside. Number 5. So my index this time is 3. So I'm looking for 3 of the same number or 3 of the same variable. So make sure you check with your index. So this is 9 and 3, 3, and 3. And I'm definitely going to use the shortcut because I'm not going to write out 12 Y's or 7 Z's. So I'm not going to do that. I'm looking for 3 of the same number. So I have 3 3's. So that is going to go on the outside of the square root. Complete groups of your index go on the outside. Everything else goes on the inside. So I'm going to use the shortcut. 3 goes into 12 4 times. And there are no remainders. 3 goes into 7 twice. And I am going to have some leftovers on the inside. So I don't have any leftover prime numbers. I used up all my numbers. 3 goes into 12 4 times, so nothing's left over. 3 goes into 7 twice, but you do have 1 that's left over. Because 3 times 2 is 6, but I'm trying to get to 7. And I do need to put my index on the outside, so I have a little 3 that's on the outside, so we do need to make sure we put that little 3 back on the outside. All right, number 6, break it on down. So 16, let's do 8 and 2, let's do 4 and 2, and let's do 2 and 2. So my index is 4. I'm looking for 4 of the same number. So 1, 2, 3, 4. I got 4 2's, so that is a complete group. So 4 of the same number. That's going to go on the outside of the square root. Definitely going to use the shortcut. 4 goes into 16 4 whole times. And 4 goes into 24 6 whole times. And I do not have anything left over. All my prime numbers were used up. That's where that 2 came from. 4 times 4 is 16. 4 times 6 is 24. I don't have anything left over. So this is our final answer. So my final answer is 2 G to the 4th H to the 6th. So my phone is ringing again. I'll call her back when I finish my lesson. All right, so this one I didn't have anything left over, so we leave my answer just like this. All right, I got a couple more that we'll go through and we'll do on the back side. So the square root of 25, A to the 4th, B to the 9th. So my index this time is the number 2. So I have a little 2 that's on the outside, so I'm looking for groups of 2. So this is going to be 5 and 5. And I'll put the index on the outside so we don't forget that we're looking for groups of 2. So I'll circle those together. All right, off we go. So 5 comes down. Complete groups go on the outside. Everything else goes on the inside. 2 goes into 4 twice. 2 goes into 9 4 times. And any leftover prime numbers or variable go on the inside. So I don't have any leftover numbers. 2 times 2 is 4. I don't have any A's that are left over. 2 times 4 is 8, but I'm trying to get to 9, so I do have 1 B that's left over. And I want to make sure with this, okay, never mind. I was looking back at the first one, but nothing was left over, so it's fine. So this is my final answer. 5A squared B to the 4th times the square root of B. And last one, last but not least, last one. The cube root of 125, M to the 30th, P to the 20th. So break down 125. Let's see, that's 25 and 5. This is 5 and 5. I'm looking for 3 of the same number. So I have 3 5s. So that goes on the outside. And we'll use the shortcut. 3 goes into 30 10 times. 3 goes into 20 6 times. We'll write the index. I don't have any leftover numbers. I used all 3 5s, so that's why that's on the outside. 3 goes into 30 evenly. That goes into it 10 times. 3 goes into 20 only 6 times. So that gives me 18 because 6 times 3 is 18. And we have 2 P's left over. So this is our final answer. 5M to the 10th, P to the 6th times the cube root of P squared. So that is our final answer.